Hello, welcome to this tutorial. If you are interested in reverse engineering or binary program analysis, this video is for you. Please subscribe our channel to get access to future videos. In this tutorial, we're gonna review some basic stuff about binary programs, and I will show you some practical examples in Ghidra. And we will review how to get this information using Ghidra. In the first chapter of this tutorial, I will show you how to write simple and basic scripts with Ghidra. But before jumping to our practical example, let's review what is a binary file. When you write your program, especially in languages such as C and C++, you may write the main part of your code in main.cpp, and you may put some libraries and functions in library.cpp, and you may divide your code into different modules. But when you compile your code, you're gonna have one binary file, which is an executable file. But let's review what happens in between. When you have your code in different modules, what happens is compiler will convert each of the C or C++ modules into object files. An object file is a binary file, but it is not executable. It means that you cannot run it on your system. In the next step, linker will link these object files into a one binary file, which is now executable and you can run on your system. This is what happened in your when you want to like compile your binary program. But in this tutorial, we will learn uh, if you want to analyze a binary file using some tools such as Ghidra, what we should do, and how we can write simple scripts using Ghidra. So in the first part, I want to show you how to extract some basic information about a binary program. When you want to start analyzing your binary program, you need to first understand what is the architecture of this binary. Is it like ARM? Is it x86? What is the architecture of the binary? And also, it's good to know like what is the format of the binary based on, the operating system that you want to run your binary on. You need to have like for example, for Linux operating system, it comes in ELF format, and for Windows, it comes in PE format. And each of these formats have different structures, so it's always good to know about the binary formats. Now I want to show you if you want to extract this information using Ghidra, what you have to do. Okay, let's start. In this example, I'm using VS Code IDE, and I have Linux. I'm using Linux operating system, um, and also I have installed Ghidra, and I assume that you installed Ghidra already. To install Ghidra, I created a video, which I will put a link to the previous video. If you haven't watched that video, please watch first before following this video. And in the previous video, I explained how to install Ghidra, which is a plugin for Ghidra. So by default, you cannot write your scripts in Python 3, in Ghidra, and you have to install Ghidra tone if you want to write your script in Python 3. Okay, now let's start writing the script. So here I have two Python module. One of them is responsible to run uh, the Ghidra script. When you want to write a script using Ghidra, you can use the GUI mode, and also you can write your script and run your script without using GUI. In this tutorial and in this video, I focus on the second option, like without using GUI, and I'll show you how you can run your script using headless analysis mode. So in the Ghidra installation directory, there is a directory called support, and in that directory, there is a file named analyze headless. Each time you want to run your script, you need that binary to run your script. So you need to run your script using this file. So here is an example of the command that you need to run your Ghidra script. As you can see, you need to first mention the path to the analyze headless file, and then you need to mention the project directory path, which the output of the generated, the generated output of Ghidra will be saved in that directory, and the name of the binary. And we have here an option, delete project. When you use this option, each time you run your script, it will make sure that you run your script in a fresh workspace, and for example, the saved analysis from the previous script is removed. And the import option is just, as its name suggests, it 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 will import your binary program. And after PostScript, the PostScript option will mention, what is the path to your Ghidra script, and you can also have, any arguments that you want to pass to your Ghidra script. For now, as a first step, I don't need that, so I will just, um, remove this option first. But I'll show you how to pass arguments to the Ghidra script. Okay. Now let's dive into the Ghidra script itself. Okay, so I want to write a Python function to print the, the the path to the binary executable file and extract some other information from the binary. So I will write a function extract binary info, and to start, you know, get the current program, the imported binary, you need to use this function get current program. But if you each time you want to understand like which functions and which other functions you have access into using these object, all you have to do is simply just print the type of this object. So um, if I print the type of this object and run my code, you see that um, the type of this object is Ghidra program database program DB. Ghidra's API are well documented, so you can simply just search for this object in Ghidra's documentation, and you can see here which functions you can access to use um, using this object. So there is one function get executable path that will get the path to the program's executable file. So I can simply print get executable path. Let's see the output. So this is the binary program this is the binary program that I import, and you can see that it prints the same thing um, that I imported. The next thing is that I'm interested in uh, the next information is the architecture of the binary. So you can explore more, and there is a function get language which returns the language used by this program. So you can simply say print current program get language. I want to also show you what other functions after by using this object returned object of get language you can get access to. So let me just print the type of get language. All right. So you see that um, the language is from x86 family. It's Little Endian, and it's a 64 bit binary. So and you can see the type is this. So if I search for this Ghidra's documentation, you'll see that these are the functions that I can get access to. One of them is get processor, and I can, print the processor. Okay, it says that it's, x86 64 family, and um, okay, now the other information is the format of the binary, which you can there's a function get executable format which returns a value corresponding to the original file format, and you can simply print print the format of the binary using Ghidra. You can definitely, by using file command in Linux, you can easily get all this information. I'll show you in a second. So you see that the format is ELF, executable and linkable, linking format. And if I can simply do the same thing in Linux by using file command. Um, you see that it's ELF, it's 64 bit, and it's from x86 64 family and the same information. So cool. Uh, this is the very first step if you want to analyze a binary using different tools. So when you want to analyze a binary, you need to get some basic information about that binary first. Now let's see if I want to get, because there are lots of functions in a binary. So if I want to print the information about functions inside a binary, such as function names, function addresses, or functions body, what I should do. So let's write another function here. I so the again the very first function you need to use is get current program, and get current program has um, has it has you can by using current program you can get access to uh something a function called get function manager, and by using this function you can get access to all functions. So I will uh you know function manager, and if you want to get the functions, you can simply say get functions to get the all list of functions. Now I want to um, just simply print the type of this function. Let's see what is the type of function, and then we can search in the Ghidra's documentation and we can understand which functions I have access to using this object. So let's, oh, um, I need to replace this with extract binary info and run the code again. Okay, you see that the output is Ghidra program database function DB. So I can simply search for this in the Ghidra's documentation, and you will see that I can have access to these functions: get body, get comments, get entry point, get name, um, and all these functions are get local variables. All these functions are interested. So let's start with get name, get the name of this function. Func dot get name, and print the func dot get entry point, which is a start of the function. um, this is a function that we are interested in. Okay, let's now um, run the program again. Okay, you see that for each function, it prints the name and entry point, which is good. There are also two other functions which might be which might be interesting, such as you sometimes you may need to, get body. Let me make sure that it's my dictation is correct. Yeah, get body. If you go to this, get body, you see that it will um, get the address set for this namespace. And if I print the type of the get body, you'll see that it's address set. So just simply search it, and you can see that I have access to these functions, which is interesting. Sometimes you need to understand the start and end of the function. You can use get mean address, the mean and max address of the function. So um, let me just simply use that to show func dot get body, get mean address, and then max max address. Let's run the code again. Yeah, you can see the output. But sometimes we are only interested in analyzing some specific functions. So, for example, this is a source code that corresponds to the binary I'm analyzing right now. And this is a function that contains vulnerability, stack-based buffer overflow, and I just want to filter based on the function name, based on the function address. So imagine that I have the function name. If your binary is not stripped, so the function names are present, which in this case, the binary is not stripped. It has debug symbols, as you can see here with debug info and not stripped. So the function names are present. So if I want to pass an argument like function name to my Ghidra script, what I can do is in the command that is running my script after the path to the Ghidra script, I need to mention my arguments. It can be, any number of arguments that I want. So the argument that I want to pass is function name. I'll add it here. And here in the main, uh, I need to, get these arguments. And because if I have like list of arguments, the first one is the function name. So we assume that the first argument is function name. If I have more arguments here, um, I need to just, get those arguments using the different index. Okay. Now I want to pass this function name into uh, this function, and I want to filter I just want to print in function information for this specific function, so I can add this filter here. If the function name is equal to the target function, just print the entry point and min and max addresses. Um, okay, let's run the script again. All right, cool. So you see that it's just, print the information for this specific function, and you can, passing your arguments in Ghidra scripts. You can filter based on the address of the function or based on the function name or whatever. So i- in this tutorial, we reviewed how to extract binary and function information. In the next video, I'll explain how to extract, how to decompile function using Ghidra. And if you are interested, please subscribe our channel and follow us on YouTube. And I hope that this video was useful for you.